Hi, today's project is working on this Helios indicator. They're a German-made indicator and I think pretty good quality. It doesn't make sense to me to send these out for repair given that the fee and the shipping both ways often exceeds the value of a used indicator, but very often you can fix them yourself. Fixing your own indicators always seems like sort of a natural thing for someone really into machining who also dabbles in watchmaking. I would say there's three main things that make an indicator fail. The first, and the thing responsible for 95 or 98% of the failures, is oil and gunk. Somebody's put oil in there. Don't oil your indicators, more on that in a bit. And using basic watchmaking techniques, this is easy to fix. The second reason they stop working is because of a cracked jewel. Think of jewels like a bearing. They have absolutely no gem value, but they're a very hard material and make a great bearing. The part that rides in this bearing is called the pivot, what you might call a journal on a larger diameter shaft. And while these jewels wear extremely well, they are fragile and they do crack sometimes, which can stop the indicator, make it sluggish, or if left, would start to wear away and eat into the pivot. Fixing these is a little more involved, and one way to do so is presented here. The last reason they stop working is just damage of parts. The thing's been dropped and teeth are bent on the rack or on a wheel. Something's badly broken, etc. Anything can be fixed with enough time and effort, but when I see an indicator like that, I usually consider it scrap. It's just not worth the cost of the parts, time to find the parts, or time to make the part. From the photos, you can see things are in fairly poor shape, lots of dirt, corrosion, rust. So the first job, and it's exactly the same process with watchmaking, you take everything apart, start to clean and inspect and find out where the problem. A couple of rings hold the crystal on. Once you get past that, time to take the hands off. I find these Helios indicators, I don't know if the hands were glued on or cemented on somehow, but they can just be the worst indicator to try to get a hand off, and I've damaged them sometimes. So use care if you're working on a Helios. I used the largest set of levers I had to get the main hand off, and then a set of watchmaker's hand removal tools to get the revolution counter off. The inner dial comes off. It's just got a couple of brass pins there that are holding it in the correct position. There's 3 clips that secure the base plate to a shoulder on the bezel. Be careful with the dials. I wash them usually with soap and water by hand. It's very easy to put too much into it and start to remove the graduation lines. Flipping it over, there's a few more parts to take apart before we can get the movement out. For brevity, I'm not going to go into every detail, as it seems like every indicator I work on is slightly different, but they're generally not too hard to figure out. Now, with everything coming apart, we can get down to a detailed inspection, and it quickly becomes apparent we've got a problem with several cracked jewels. With a watch, you'd simply replace the jewel, and that would be the end of it. However, it's problematic to source these jewels for indicators. If you look at the photograph, I've included an X-Acto knife as a size reference beside the cracked jewel, and then also placed a ruby-colored jewel, typically of the size that you'd use in watchmaking. Watch jewels are inexpensive, but these larger sizes are rare, and the people that do sell them seem quite proud of them, enough so that it's just not worth it in my opinion. Fortunately, a 3mm by 1mm miniature ball bearing available from most of the usual online sources is almost a perfect substitute. You can see in the photo that the jewel is held in a sort of small brass cup that then is pressed into the plate. This is called a chaton, and I'm going to do the same thing to hold the ball bearing in place. Make the chaton inside diameter fit the bearing OD, and then have it press into the plate. A while ago I set up a small turret lathe to make a whole bunch of chatons so that I'd have an inventory for this sort of work. It's fidgety work because you want a very light press fit both into the plate and on the bearing. So I thought once I get it dialed in once, I'd build up an inventory. The chaton and bearing are pressed into the plate using a staking tool. Because of the riveted ends of the posts that are mounted through the plate would not sit flat on the staking tool table. So I ended up with some of the chaton pressing through the other side proud of the plate. I set the work up in a watchmaker's faceplate and packed watchmaker's Rodico into the bearing to keep all of the chips out of the bearing, and then face the chaton to be flush with the plate. Next, I need to turn down the pivots to fit the 1mm ID of the ball. My goal is a very close sliding fit. Standard fare in watch or clock work is to burnish the pivots. A watchmaker's burnisher tool is sort of the same shape and size or form factor of a needle file, except it's a piece of hardened steel with extremely fine grooves in it put in by a piece of emery cloth perpendicular to the long axis. It removes almost no material. The act of burnishing is really moving metal around by plastic deformation, pushing the peaks into the valleys sort of thing. I say almost no material because if you look at the oil after burnishing, you can see a slight gray tinge to it, indicating there's some metal particles there. However, it's almost nothing. The mainstay of cleaning is this L&R watch cleaner. I don't think anything else does quite as nice a job. I'm using the L&R wash, which you can see right now. And then there's 2 stages of rinse followed by some exposure into a hot area that dries everything off. All that's needed now is to polish the screw heads and finish putting this back together, and this indicator is good to go. So, how did this work out? This is the Helios, and it's a very nicely made hardwood box with a purple felt liner, how a quality tool should be packaged. And the action is very smooth and very fast with no sticky points. I mean, there's just no issues there. That's exactly what you want it to do. Beautiful, clean indicator. I promised to come back and talk about this no oiling advice. It probably seems counterintuitive in that all of us mechanical types know that moving parts need lubrication. But the view changes when you layer in some watchmaking knowledge around lubrication. But the 2 key things are, first, that the geometry of a pivot and jewel in a watch are specifically the way they are so that the surface tension of the oil can hold the oil in place. This is either not present or just wouldn't work given the size with an indicator. With watch work, knowing how to oil is slightly complicated and absolutely crucial to success. If you don't put the right amount of oil on for the geometry of the particular situation that you have, surface tension will not hold the oil in place and it will run off. Tiny needle-like tools with a spade shape forged on one end are used to pick up a drop of oil. A watchmaker will have several different sizes for different sizes of geometry, so as to avoid ever putting on more oil than he wants. Because with too much oil, that's what prevents the surface tension from keeping the oil in place. And there are specific shapes to the jewels to work with the oil surface tension to keep it where it's supposed to be. The whole process is quite tentative, requiring special technique, special equipment, and it's an area that beginners constantly mess up on. There is just not the same geometry to a jewel in an indicator. The second really key thing to be aware of is that a mechanical watch needs to be fully serviced every 3 to 5 years. That means complete disassembly, cleaning, and relubrication. The reason for this is that even though a watch is far better sealed than an indicator, stuff manages to get in and contaminate the oil and turn it into a pasty, semi-abrasive mess that does more damage than good. So you can see the challenge. For an instrument to work with oil, it must be regularly serviced, and that just doesn't happen with indicators. Nobody regularly sends their indicators out for servicing, which would be a requirement if you were to start oiling your indicators. An engineer's view might be that the journal bearings in an indicator experience extremely light loads, low speeds, and compared to a watch, an infinitesimally small duty cycle. They do better dry, last longer, and keeping them dry avoids the most common thing that stops an indicator, dried up oil and gunk. Finally, I've seen and worked on a lot of indicators. 95, 98% of the time, the indicator stops working because there's oil and crud in there that needs to be cleaned out. Some of the time they stop working because they've been dropped and physically damaged. And some of the time they stop working because there's a cracked jewel. But I've never seen one stop working because the pivots are worn out. In my opinion, you are better off to leave your indicator dry. Thanks for tuning in. I hope that was of benefit to some.